In this example on page 364, number 53, height and age. Are older men shorter than younger men? According to the National Health Statistics Report, the mean height for U.S. men is 69.4 inches. In an example of 300 men in a sample of 300 men between the ages 60 and 69, right? So this is a subgroup of all U.S. men. The mean height was 69.0 inches. The public health officials want to determine whether the mean height, mu, for older men is less than the mean height for all adult men. So is the height of this subgroup different, significantly different than the all adult men? Okay, is it less? So the first thing we want to do is we want to figure out what we are testing, right? The null hypothesis. Right? Anytime we're testing a subgroup against the original group, the null hypothesis is always going to be that they're the same, right? The null hypothesis is that the mean for this subgroup is exactly the same as the population. Right? So it's 5'9" and almost a half inches. Okay. The alternative hypothesis in this case, we look for our key words. Right? We're testing in this case against less. Right? So the mean for this subgroup would be less than the 69.4 inches. All right, so in the hypothesis test, we assume the null hypothesis. We use our data to test to see whether that null hypothesis is reasonable given our sample data. Okay. So in B, the population standard, assume the population standard deviation is the 2.84 inches, right? So there's enough data for the men's population at large to assume that this 2.84 is true. So we actually know population standard deviation. Right. It's an assumption that it still holds for this subgroup, but if it's true for the population at large, it's a reasonable assumption, and it's a pretty good assumption. All right. So compute the value of the test statistic. The test statistic in this case is always going to be either the t or the z, depending upon whether we know the population standard deviation or we don't, right? So in this case, since we know the population standard deviation, we can use the z's. If we didn't, we would have to use the t's, but we do in this case, so we know we can use the z's. We have access to the full standard normal distribution. All right, so I'm going to do this using the calculator, and the approach, the thing we're going to do is we're going to do a z test, since we can use the z's since we know the population standard deviation. All right, so on our trusty rusty TI calculator, we go to Stat, Tests, and then we do a z-test, which is 1 if you prefer the numbering scheme. Okay, in this case, we have the statistics. So the input, right, there's data, stats. I want to choose this one. Our null hypothesis goes in the mu. That's our 69.4. The population standard deviation, we know in this case that's the 2.84. The sample mean is for our men between 69 and 80, right? So that's our 69 in this case. And our sample size is, you can see it, but I can't because I have something on my screen, 300 in this case, okay? We're testing against the less than. So not mu naught, less than mu naught, greater than mu naught. We're testing against the less than. And if we do the calculations, we get that my test statistic, my z, is negative 2.44. Right? So what that means is that if I assume my 69.4 is in here, right, is the center of this normal distribution, my z would be my negative 2.94, right? That's where the 69 would appear for this normal distribution, okay? If we're going to do a hypothesis test, most of the time we care about the p-value, 0.00735. But the test statistic is this thing. This tells us the area under the curve to the left, since we did a left-tailed test, of my 69 inches for my sample, right? That's the area under the curve, right? So this is the thing that we're going to test against alpha. All right, so summarizing where we're at, my null hypothesis was 69.4. My alternative hypothesis was less than 69.4. We know the population standard deviation 2.84. The sample mean was 69 for a sample of 300. Running our z-test, we had a test statistic of negative 2.44, and our p-value was 0.0074. So for our hypothesis test, we're testing against 0.001. We had our p-value of 0.0074. Right, so the p-value, oh no, there's too many zeros in that alpha, 0.00, dear Lord, 0.01. Right, alpha is greater than p, right? So p is less than alpha. Alpha is greater than p. If the p is less than alpha, we reject the null hypothesis. It's not reasonable to assume that these older men still have the same average height. So my conclusion, I would say something like this. Right, so I would say something like, according to the NHS report of 300 men between the ages of 60 and 69, there is enough evidence to conclude that men in this age group are shorter on average than the 69.4 inches average of all U.S. men. I should probably put that word in there. Okay. All right, so that's what we can conclude from this, right? So the evidence is that they are shorter. But this is one study. One study doesn't prove anything, but it is a data point, and the evidence in this study does indicate that they are shorter on average.